Okay, let's take a look at number 9 in section 4.2. We're going to find all the critical points of this function here on the interval from 0 to 3, and then find extreme values on that closed interval. Okay, so where we start is the derivative of this function, which is a piece of cake. Hopefully everyone's good with how to get that using the sum difference rule, constant multiple rule, power rule, constant rule. Well, I guess we don't have a constant rule, but there's the derivative, right? Hopefully that makes sense. So this derivative is never undefined, right? But it is equal to 0 when? Well, if I could factor this expression, that's what I would do. But if you try and factor this, you'll see that this is actually prime. It's not something you can factor over the rational numbers, right? So what do you do in that case? Well, now we go to the Pythagorean theorem. And sorry, not Pythagorean theorem. Go to the quadratic formula. I don't know what I'm saying here. So, right, the quadratic formula, everyone should be familiar with that. If not, it's on the help sheet here, but you should be familiar with that from pre-calculus days. And so that's what I'm going to use, right? The value of A is 15, the value of B is negative 34, and the value of C is 9. And so doing that evaluation and simplifying gets me down to here. Now, the square root of 616 can be simplified because 4 is the largest perfect square factor of 616. And so I can break this up as the square root of 4 times the square root of 154. And of course, the square root of 4 is 2. So the square root of 616 is 2 times the square root of 154. And now 34 and 2, I can factor a 2 out of, leaving 17 plus or minus the root of 154. And then 2 and 30 have that common factor of 2. And so I can simplify down to here. So this is the simplified expression. These are the critical points. If you use your calculator to approximate these, it's about 1.96 and 0.31, which notice both are in the interval from 0 to 3, and that's important. You only wanted the critical points that are on this interval. So if a critical point came out to be like 3 point something, 3.5, you wouldn't list it because it's not in this interval in this particular problem. So they're only interested in those. Of course, Achieve wants you to list them exact and with separated by a comma. Okay, now the second part of the problem after finding the critical points was to find the extreme values on the interval. The way you do that is you check the value of the function at the endpoints 0 and 3 and at these critical points. So I just used my calculator to do that. And just showing you real quick what that looks like. You know, I put in the original function, of course, back to our original function here. And then I go to table and I plugged in 0 and 3. Now here, what I did is I just simply, to plug in this critical point, I just did, you know, exact in parentheses 17 minus the square root of 154, right, in parentheses for the numerator divided by 15, and then hit enter, and it gave me that value, but more importantly, it gave me the output there. So I rounded to 3 decimal places because that's what they in the instructions ask for if you have to round to give it to 3 decimal places. So I would round that to 1.305. I also typed in this 17 plus the square root of 154 divided by 15 and got that. And there's the output. Notice when I highlight it, notice I can't see 3 decimal places here, but highlight it and you'll see all the decimal places the calculator has. And so going to the 3rd decimal place, notice there's a 9. The next one's a 5, which rounds that 9 or the 19 up to 20, right? So it's negative 10.020. So remember your rounding rules. So now what's the maximum? You just look at which is the biggest number here, and the biggest number is 9. So that's the maximum value. Which is the smallest number? Well, obviously negative 10.020. Okay. So I hope this is helpful on this one. Let me know if you have questions.